In 1967, a Japanese company stared down the American giant that ruled every construction site on Earth and made a promise that sounded completely insane. We will encircle Caterpillar. Nobody laughed for long. Within just a few decades, Komatsu was building hydraulic excavators so enormous that a single bucket could swallow a small car, and machines so intelligent they dig entirely by themselves. These are 10 Komatsu excavators that didn't just compete, they rewrote what a digging machine could be. Number 10. The Komatsu PW series. Before Komatsu was a giant, it was a student. Founded in 1921 and named after the city of Komatsu in Japan's Ishikawa prefecture, the company spent decades building bulldozers, tractors, and engines, not excavators. When it finally wanted in, it licensed expertise from the American firm Bucyrus Erie, and out of that partnership came its first hydraulic excavator in 1968, the seed every monster on this list traces back to. But here's the Komatsu most people forget. Picture a digger. You're picturing steel tracks, aren't you? The PW series throws that assumption out. It's a full-size hydraulic excavator that rolls on rubber tires. That sounds minor. It isn't. A tracked excavator needs a trailer, a truck, and permits just to move down the road. A wheeled PW simply drives there under its own power, weaves through a city center, and digs the moment it arrives. For Europe's cramped urban job sites, that was a revelation. Komatsu opened its first overseas subsidiary in Belgium in 1967, and the PW family was built for that world. Rugged road-legal machines like the 20-ton, 180-horsepower PW207, swinging buckets up to 1.5 cubic meters. Why does this belong at number 10? Because it captures the instinct behind this entire countdown. Komatsu didn't just copy the standard excavator, it questioned whether the standard was even right. Tracks weren't sacred. That same rule-breaking DNA, born under the internal battle cry Maru-C, encircle Caterpillar, would eventually produce self-digging robots and 800-ton titans. Number 9. The PC-02. While most of this list is about machines getting bigger, number 9 shocked the world by going small, really small. In 1976, Komatsu built the PC-02, its very first mini excavator. And it wasn't just a shrunken version of a big digger. It introduced clever ideas that defined the entire compact excavator category that would explode in popularity decades later. The PC-02 used a boom slide and boom swing system, which let the operator offset the digging arm to one side. That sounds technical, but the real-world result was huge. The machine could dig a trench right alongside a wall or a fence without repositioning the whole body. For tight urban job sites, narrow alleys, and confined spaces, that was a revelation. The kind of work that used to require hand-digging crews could now be done by one operator on a machine small enough to maneuver almost anywhere. There's a fascinating detail in the PC-02's history that tells you exactly where Komatsu was headed. When Komatsu launched its independent PC series in 1980, the PC-02 was renamed PC-20 to fit the new naming scheme. In other words, this little machine was the bridge between the Bucyrus licensed era and the all-Komatsu future. It was, in a real sense, the first member of the PC family, the lineage that would eventually include the largest hydraulic excavators on the planet. The world wouldn't fully appreciate mini excavators until the 1990s and 2000s, when compact machines became some of the best-selling construction equipment on Earth. But Komatsu was already there in 1976, sketching the blueprint. Number 9 proves that shocking the world isn't always about brute force. Sometimes it's about seeing a need decades before anyone else does and quietly building the answer. Number 8. The PC-1 series and the PC-200. For more than a decade, Komatsu built its excavators under license from Bucyrus Erie. Useful, but it meant Komatsu was, in part, building someone else's designs. Number 8 is the moment Komatsu cut the cord and bet everything on its own engineering. The technology tie-up with Bucyrus Erie was terminated in early 1981. Right around that pivot, in 1980, Komatsu launched its first fully independent excavator family, the PC series, starting with the PC-1 generation. The PC branding you still see on every Komatsu excavator today began right here, and the engineering had something to prove. The PC-1 introduced a pump-neutral system designed to cut fuel consumption by minimizing wasted output from the main hydraulic pump. Then came the machine that turned Komatsu into a household name on job sites worldwide, the PC-200. Roughly a 20-ton class excavator, the PC-200 hit the sweet spot of size, power, and versatility that makes up the single most popular excavator category on Earth. In 1982, the PC-202 introduced a genuine breakthrough, OLSS, the Open Center Load Sensing System. It was Komatsu's first real energy-saving hydraulic system, cutting the power loss that normally occurred when the control levers sat in neutral or during fine, precise movements. Why does a hydraulic efficiency system count as shocking the world? Because fuel and productivity are everything in this business. An excavator that does the same work while burning less fuel and offering smoother control isn't a gimmick, it's a profit machine. The PC-200 line became a global benchmark, the digger that competitors measured themselves against, and it remains one of Komatsu's most iconic model families to this day. Number 8 is where Komatsu stopped being a licensee and became an innovator. The student had graduated and was about to start teaching. Number 7. The PC-650. Once Komatsu had its own platform, it started thinking bigger. Number 7 is the PC-650. Introduced in 1983, a large loading shovel that pushed Komatsu into heavier territory and carried a nickname that engineers still smile about. The PC-650 was built for serious work, gathering gravel and soil, handling crushed stone, loading at quarries and large sites. To control a machine this size with the precision operators demanded, Komatsu fitted it with an electrically controlled hydraulic system, the same advanced approach used on its larger PC-1500. This was the era when Komatsu leaned hard into Mechatronics, the marriage of mechanical engineering and electronic control. Using electronics to manage engine and hydraulic behavior was, at the time, a showcase of Japan's surging lead in electronics technology. But cutting-edge tech comes with growing pains. The hydraulic plumbing on the early PC-650 was so dense and complex that the people developing it gave it an affectionate, slightly exasperated nickname, the Jungle Gym Spaghetti Tube. Picture a tangle of hydraulic lines so intricate it looked like a climbing frame wrapped in noodles. It's a wonderfully human detail in a story usually told through cold specifications, proof that even legendary machines are built by engineers wrestling with real problems. The story has a payoff. The plumbing nightmare got sorted out, and quality improved dramatically with the upgraded PC-653. That refined platform became the foundation for an even bigger generation. The PC-750 and PC-800 followed directly from lessons learned here. In other words, the PC-650 was Komatsu's proving ground for building large, electronically controlled excavators reliably. Number 7. Shocked the world less with a single headline and more with a trajectory. It showed Komatsu could scale up, master electronic hydraulic control, and turn a tangled prototype into a dependable workhorse, exactly the capabilities it would need to eventually build the largest diggers on the planet. Number 6. The PC-2006. By the mid-1990s, Komatsu had conquered the standard and large excavator classes. Number 6 is where it stepped firmly into the world of true giants. In 1995, Komatsu introduced the PC-2006, which at the time ranked among the largest hydraulic excavators in the world. To understand the leap, remember where this story started. A modest Bucyrus-based machine in 1968. Less than 30 years later, Komatsu was building a hydraulic excavator weighing on the order of 200 tons, designed for the brutal, around-the-clock demands of large quarries and mining operations. Machines in this class don't tidy up construction sites, they tear into the earth itself, loading enormous haul trucks pass after pass after pass. The PC-2000 mattered because it was a statement of independent capability. Building a machine this large isn't simply a matter of making everything bigger. The hydraulics have to deliver colossal force without overheating or failing. The structure has to survive impacts and stresses that would shatter a smaller machine. The cooling, the durability, the serviceability, every system has to be re-engineered for a scale where downtime costs a fortune. Komatsu had developed all of that in-house, building on everything it learned from the PC650 and the generations that followed. This is also the period when Komatsu's global footprint exploded. The company had established operations across Asia and beyond, and its mining-class equipment was increasingly competing head-to-head with the biggest names in the industry, including, of course, the Caterpillar it had vowed to encircle decades earlier. Number 6 is the moment the underdog became a heavyweight. The PC2006 proved Komatsu could design and build a world-class giant entirely on its own engineering, and it set the stage for an acquisition that would make Komatsu's mining excavators truly unstoppable. Number 5. The PC4000 and the Demag heritage. Here's where the Komatsu story takes a dramatic turn, and where the machines start to look genuinely otherworldly. Number 5 isn't just one excavator, it's an entire bloodline that Komatsu absorbed from one of Germany's most storied heavy equipment makers. The German firm Demag had a deep history in excavation, with roots tracing back over a century. Demag built its first fully hydraulic excavator, the B504, back in 1954. In 1972, it produced its first 100-ton hydraulic shovel, the H101. In 1978, it built its first dedicated hydraulic mining shovel, the H241. And in 1986, Demag created what was then the world's largest hydraulic mining shovel, the H485, a true colossus. Komatsu saw the value immediately. In 1996, the two formed a joint venture called Demag Komatsu GmbH. Then, in 1999, Komatsu acquired the operation outright, renaming it Komatsu Mining Germany. With that single move, Komatsu didn't just buy a factory. It inherited decades of expertise in ultra-large hydraulic mining shovels and a lineup of legendary German-engineered giants. In fact, the Komatsu PC3000 you can buy today is essentially the old Demag H185, refined and rebadged, with over 200 units built across both names. The crown jewel of this acquired family in the working range is the PC4000. This is a machine on a scale that's genuinely hard to picture. It tips the scales at roughly 398 to 409 tons. Its bucket holds about 22 cubic meters of material. Its engine puts out around 1,400 kilowatts, nearly 1,900 horsepower. And it's purpose-built to load haul trucks in the 150 to 240 US ton class. Number 5 shocked the world because of what it revealed about Komatsu's ambition. The company that started by licensing American designs in the 1960s had grown powerful enough to acquire a century-old German engineering dynasty and fold its record-setting giants into the Komatsu badge. The mining world's biggest machines now spoke Japanese and German at the same time. Number 4. The PC 5500. If the PC 4000 sounds enormous, number 4 makes it look like a warm-up act. The Komatsu PC 5500 sits one rung higher on the ladder of giants, and it's the machine that bridges the gap between very large excavator and barely comprehensible mining monster. The headline number is the bucket. The PC 5500 carries a bucket with a capacity of around 29 cubic meters. Stop and think about that for a moment. 29 cubic meters is roughly the volume of a small swimming pool, scooped up, lifted, and dumped in a single motion, then repeated all day, every day. A machine like this exists for one reason: to move staggering quantities of rock and ore at the lowest possible cost per ton. The PC 5500 came out of that same Komatsu Mining Germany operation, the former Demag Works, and it carries the German giant's DNA forward. It was introduced in the mid-2000s with a Tier 2 emissions version featuring the big 29 cubic meter bucket shown off at the major MINExpo mining trade show in 2008. Like its siblings, it can be ordered with either a diesel or a fully electric drivetrain, because at this scale, many mines run permanent power lines to their excavators to slash fuel costs and emissions. What makes machines like the PC 5500 quietly shocking isn't just their size, it's their endurance. These excavators are engineered to run essentially non-stop. Komatsu has noted that one of its big mining shovels racked up almost 170,000 working hours, the equivalent of more than 15 years of continuous 24 hours a day, 365 days a year operation. That's a level of durability that would be unthinkable in almost any other machine on Earth. Number 4 is the machine that prepares you for the final reveals. Because as massive as the PC 5500 is, Komatsu builds something bigger still, and the next two entries are where this story goes from impressive to almost unbelievable. Number 3. The PC 8000. This is the big one. Number 3 is the Komatsu PC 8000. For years, the largest and most powerful hydraulic excavator in Komatsu's entire range, and one of the largest hydraulic excavators ever built by anyone. Let's start with the weight, because it's almost impossible to believe. Depending on the generation, the PC 8000 weighs in the neighborhood of 685 tons for the original version, introduced around 1999, climbing to roughly 777 tons for later variants. That's not a typo. A single excavator weighing the better part of 800 metric tons, more than a fully loaded jumbo jet. Now the bucket, about 42 cubic meters. That's the figure behind the swallow a small car comparison. A bucket so cavernous you could park a vehicle inside it with room to spare. The latest PC 8011 generation is driven by two engines together, producing around 3,000 kilowatts, roughly 4,000 horsepower combined. It's designed to load the absolute largest haul trucks on the market, in the 240 to 400 US ton class. And under optimal conditions, Komatsu states the PC 8000 can move up to around 6,800 tons of material every hour. 6,800 tons per hour from one machine. Everything about the PC 8000 is built for a world humans rarely see. The deepest open-pit mines on the planet, in some of the harshest environments on Earth. Getting on board means climbing a 45-degree access ladder. The cab sits 2 or 3 stories up. It comes with multiple dedicated emergency escape systems, because a machine this large is its own small building. The economics behind it are as staggering as the dimensions. A machine like this isn't sold by the thousand. Each one is effectively built to order for a specific mine, with customers choosing bucket sizes, wear packages, cooling systems, and even diesel or electric drive. Komatsu manufactures more than 70% of the parts in its excavators in-house, which is part of how it keeps these one-of-a-kind giants running in places where a breakdown can cost a fortune in lost production every hour. And run they do. The PC 8000 and its siblings are engineered for relentless, around-the-clock duty in pits where the temperature can swing from freezing to scorching. The whole design philosophy is summed up in one phrase the mining industry lives by: lowest cost per ton. When you're moving up to 6,800 tons an hour, even a tiny gain in efficiency translates into millions of dollars over a machine's life. Number 2. The PC 208 Hybrid. After the raw, earth-shaking power of the PC 8000, Number 2 shocks the world in the opposite direction, with intelligence and efficiency. In 2008, Komatsu launched the PC 208 Hybrid, and it earned a title no competitor could claim: the world's first hybrid hydraulic excavator. We're all familiar with hybrid cars that recover energy when you brake. Komatsu applied the same principle to a completely different motion. Think about what an excavator does thousands of times a day. It swings its upper body left and right to dig and dump. Every time that heavy rotating structure slows down and stops, a tremendous amount of energy is normally just thrown away as heat. The PC 208 Hybrid captures that swing braking energy, stores it, and then releases it to boost the engine when extra power is needed, for example when accelerating the swing again or working the hydraulics hard. The result was remarkable. The hybrid version consumed, on average, roughly 35 to 40% less fuel than the standard PC 208 doing the same work. In an industry where fuel is one of the single biggest operating costs and where machines run for thousands of hours a year, that kind of saving is enormous, both for an owner's wallet and for emissions. It's worth appreciating the audacity here. In 2008, hybrid technology was still novel, even in passenger cars. Komatsu chose to pioneer it in a 20-ton construction machine that has to survive mud, dust, vibration, and brutal duty cycles, and it made it work in series production. This wasn't a one-off concept for a trade show. It was a real viable machine that put Komatsu years ahead of the field on excavator efficiency. Number 2 shocked the world by proving that the future of digging wasn't only about getting bigger and stronger, it was about getting smarter. And that idea sets up the single most futuristic machine on this entire list. Number 1. The PC210 LCI-10 for our number 1. Forget brute force entirely. This is the machine that, more than any other, signaled where the entire industry was heading. In 2014, Komatsu began the worldwide launch of the PC210 LCI-10, the world's first intelligent machine control hydraulic excavator. An excavator that, in a very real sense, helps dig itself. Here's the magic. A traditional excavator is only as accurate as its operator's eye, and big jobs require armies of surveyors planting stakes everywhere to mark grades and depths. The PC210 LCI-10 throws that whole workflow out. It uses satellite positioning, GPS and GLONASS signals combined with stroke-sensing hydraulic cylinders and an inertial measurement unit to know the exact position of its bucket teeth in three-dimensional space at all times. You load a 3D design of the finished job into the machine's computer, and then something extraordinary happens. As the operator digs, the machine compares the bucket's real position against the design in real time. When the bucket teeth reach the target surface, the system automatically controls the boom, arm, and bucket so that they trace the design surface and simply will not dig deeper than they should. The operator literally cannot over-excavate. The machine semi-automatically follows the planned grade, completing precise finish work in a fraction of the usual time and with almost no risk of error. This wasn't a guidance system that beeps and shows arrows on a screen. It was full, factory-integrated semi-automatic control, the first of its kind on any excavator in the world. It came after Komatsu pioneered the same idea on its bulldozers, and the excavator version was first shown at the Boma Trade Fair in 2013 before its global rollout. The groundwork is worth appreciating. Komatsu had already rolled out a family of intelligent machine control crawler dozers, machines like the D51 and the D37 and D39, featuring what it billed as the world's first automatic blade control system. The excavator took that hard-won technology and adapted it to a far trickier task. An excavator's bucket moves through 3 link joints, swings and reaches, so the math is much harder than a dozer pushing a blade. Komatsu solved it with proprietary stroke-sensing cylinders on the boom, arm, and bucket, married to satellite positioning, and delivered grading accuracy measured in mere fractions of a foot, the kind of precision that used to demand a skilled operator and a survey crew working together. The productivity gains were staggering. Komatsu's later second-generation model, the PC210 LCI-11, was stated to deliver up to a 63% improvement in excavating efficiency compared to a standard PC210 LC machine, with European customers reporting productivity jumps around 30%. It cut the need for surveyors near the machine, improving safety, and it let a less experienced operator produce expert-level results. Number 1 is the perfect bookend to this story. We began with a Japanese company humbly licensing American excavator designs in 1968, unsure if it could even compete. We end with that same company introducing a machine so advanced it semi-automates one of the oldest, most skill-dependent jobs in construction and selling it to the world first. From the 15H to the self-digging PC210 LCI, Komatsu didn't just catch the giants it set out to encircle. It started leading them into the future. If you enjoyed this deep dive into the machines that built our world, hit that subscribe button and the bell so you don't miss the next one. And let me know which manufacturer you want me to cover next. Caterpillar, Hitachi, Liebherr. Until then, keep digging